Hopefully none of you are bothered by this slightly bent up paper. There's not much I can do. I don't want to waste paper. Anyway, so we're going to talk about the next chapter now. This is where square roots and cubic roots and fourth roots come in. Okay, and we're going to talk about roots of real numbers for this particular section. So later we'll talk about imaginary numbers. I know, weird that they're imaginary numbers and real numbers, but today we're just talking about real numbers. So we're going to solve each of these: square root of 64, square root of negative 64, etc. Okay, first of all, 8 times 8 is 64, which means the square root of 64 is 8. Okay, and then also negative 64. Okay, well, there's no two of the same number that can multiply to a negative, right? Because negative 8 times 8 is negative 64. So that is not a real solution. So there's no square roots of negative numbers. Okay, a cubic root, if I take a little tree of 64, I realize that it's 4 times 4 times 4, so the cubic root of 64 is 4, and the cubic root of negative 64 is going to be negative 4, because a negative times a negative times a negative is a negative. Okay, just remember that square roots of negative numbers, that's a bad thing. We don't like that. Okay, so ignore, that's always going to be not a real solution when you see that. Same thing if it's the fourth root, it'll also be not real if there's a negative underneath the fourth root. Okay, we have some fractions now. One thing that you should know is that you can split up the square root to the top and bottom of a fraction. So it's going to be square root of 1 over square root of 16, which is 1 over 4. And then the same thing happens in the next one, so it becomes 9/4. And then obviously the square root splits, or sorry, the fourth root splits in this one. And then I notice that 16 is 2 times 2 times 2 times 2. So that becomes 1/2. And then the last one, 81, is 3 times 3 times 3 times 3, so it becomes 3 over 2. So those all simplify quite simply. You just have to split the roots to the top and the bottom of the fraction. Now let's suppose that we have an a. Okay, so it's a variable, so it switches things up a little bit. Now whenever I just have the direct square root or something like that, I'm always looking for the positive solution, so that's just a note here. So let's look at this first one. So a squared is always going to be positive because any number squared ends up as a positive. Any real number squared is a positive. Now if there's a negative on the outside there, then that means I'm taking the square root of a negative number, which is not good, right? So this is not a real solution. However, the parentheses here make this basically a squared, positive a squared. So then the square root of a squared is just a, but then I'm going to put these absolute values on the outside just to show that this is a positive solution. I always give a positive solution for square roots, for fourth roots, for sixth roots, any even root. I'm going to give a positive solution. So the same thing happens in the next one, the absolute value of a, not just a, because a might be a negative number, so I'm trying to show that it's a positive solution. And then in the last one, the square root of a to the 6 is a cubed, and a cubed can be negative, so we put an absolute value on that as well. Now we're going to be solving for a variable, so suppose y squared minus 7 equals 0, so therefore y squared equals 7. And in the next one, we have this big long thing which I'm going to solve for y squared, so I get y squared is equal to 1 over 25. Now in order to solve this, I need to take the square root of both sides, but very important, I'm going to, when I solve, say that y is equal to plus or minus the square root of 7, because either the positive or the negative solution will work for y. And same thing with the second one, y is equal to plus or minus 1/5. Okay, the plus or minus is very important when you're solving for a variable that has a square on it. Otherwise, you don't include that plus or minus. It's only when you're solving for a variable. I want to see when this particular this particular formula or equation, when these are equal. Okay, so I may think, okay, well, maybe I need to like solve for a. That's a little bit weird. Let's go ahead and just think about this rationally and kind of reason through it. So suppose I put 3 in. Okay, that means 2 minus 3 is a negative number, negative 1, but this is a square root, right, on the other side, which is always positive, okay? That's always positive, which means that I need to have the right side of the equation be positive, which means I need to have a less than or equal to 2, okay? Because 5, 2 minus 5 is negative, right? So I need to have a less than or equal to 2. So let's just test something. If I plug in negative 1, I get 2 minus 1, which is equal to 3. And on the other side, it's negative 1 minus 2 is equal to negative 3. And then if negative 3 is squared, then it's 9. And if you take the square root of 9, then it's 3. So therefore, the right and left sides are both 3. They're equal. So we're good. Okay, so a is less than or equal to 2. Okay, so now I'm going to try to figure out which values for x give real solutions for these 3 different expressions. Okay, so what values of x are going to give a real solution? I have a square root, which means I don't want to have negatives under the square root. Okay, so for the first one, I want to have 4 minus x, which is underneath the square root. I want that to be positive, right? Another way of saying that is greater than or equal to 0, which means that x is less than or equal to 4 if we just rearrange that. So that's quite simple. The next one, obviously, I want to have 4 minus x squared now to be greater than or equal to 0, to be positive. So if I rearrange, I end up getting x squared is less than or equal to 4, or x squared minus 4 is less than or equal to 0. I'm going to factor that into x minus 2. X plus 2 is less than or equal to 0. And then I do my 2 graphs, if we remember that from a previous chapter. And we've got closed dots because it's less than or equal to 0. And then I put my negatives, I put my positives, and I realize that the only section that yields less than or equal to 0 that yields the negative is that middle section. So negative 2 is less than x, or is less than or equal to x, is less than or equal to 2. And then the third one, that's a cubic root, which means it actually doesn't matter if the thing on the inside is negative or positive, which means that all real numbers are possible for x. Good luck on your homework and have a great day.